Hello, let's talk about MPI point-to-point communication. I am José Pedro Santana Neto, and here we have the basic concept of MPI communication, which is blocking communications. So, blocking means that the sending process will wait until the complete message has been correctly sent, and the receiving process will block while waiting to correctly receive the complete message. So basically, we have two process A and process B, and then the process A wants to send a message, and then this process will be blocked until everything's fine, until we send the message, and then to another case, the process B, until the process B will receive this message. So there are two basic examples of blocking communication, which is MPI send and MPI receive. So as we have previously, we have a process A that wants to send a message to process B, and then we have the data here, and in the process A we call MPI send this function from MPI framework. And here we have an explanation overview of MPI send. This comes from the documentation. MPI send performs a blocking send. In other words, we send the message, and then the process A, for example, that wants to send this message will be blocked. We will waiting for in order to complete this process. We have the signature of this function, which is the data that we want to send, the size of this data that we want to send, the data type, the destination, which is the process B, the tag, and the MPI communication. And here we have an important note, which is this routine may block until the message is received by the destination process. In another side, we have the process B, and this process B wants to receive the message from the process A. In order to do that, we need to implement and call the MPI function receive inside of this process B. Here we have the signature of this method, MPI receive, blocking receive for a message. And here we have the data that we want to send, the size of the data, the data type, the source, which is process A, the tag, and the MPI communication, and the status. Okay, good. Now we have some applications of these two basic methods of blocking communication. The first application is sequential broadcast, which is we need to share message, the same message between this process here, between all the process that we want, which is the broadcast message. In order to that, to do the sequential broadcast, we start calling MPI send from process 1 here, and then we can think about a for loop which will be iterating from process 2 to process 6, and then we need to call MPI send from process 2 to process 6. And then after that we need to call MPI receive in the same process here from 2 to 6. Okay, good. We have another application, the ring sequential. So the ring sequential is pretty similar than the previous one, but the challenge here is we need to send from 0 to 1 to 1 to 2 to 2 to 3, and then from 3 to rank 0. Basically here we need to call MPI send from 0 to 1, and then MPI receive from 0 to 1, and then so on so on. Here we need to take care of, it must be aware of deadlocks, send from even to odd and send from odd to even. We need to take care of all these 2 points here. And then we have another application which is pretty good, the Hypercube broadcast. So the Hypercube broadcast starts from process 0 here, dimension 0. And when you have dimension 1, the process 0 will send the message from 0 to 1 here. And then when you go to the to the dimension 2, the process 0 and 1 will send a message to 2 and 3, for example, here. So we have like another dimension here, and in the same pattern we have the dimension 3. Basically this, for process here, will send a message here to another face of this cube, and then we can think about the for loop, like from 0 to 3 dimensional, and then we can get like a Hypercube broadcast. And then that's it. Thanks a lot.